I say this is function f, and x is here and y is here, we know that f of x is equal to y. Here, domain of function f of x is set A, and the range or the image, we can say, of function f of x is set B. Till here, do we have any question?
No.
Now, something now I am defining based on A and B again, but now B is here, A is here. Now the function is from B to A. So in B it was Y. So in A it was X. So I am saying that if this is F inverse X, this is the notation. This notation means it's not equal to 1 over F. It's not true. F inverse means inverse function of f. Okay, so here I can say that f inverse y is equal to xy in function f inverse. Now this is domain. In the domain, what I put, I get the image. So now I want to combine these two things. Look at now. Be careful, it's very important, and it's very, how can I say, important definition, rule, or tool to solve difficult questions. In the future, if you see difficult questions, this is a very good way. F of x is equal to y if and only if f inverse y is equal to x. You should keep this as a rule in your mind. F of x is equal to y if and only if f inverse y is equal to x. Let me write one example. This is 1, this is 2. So this is 2, this is 1. So what can I say? F of 1 is equal to 2 if and only if f inverse 2 is equal to 1. Just check it, please. These two things, this one and this one, match or not. Can we say f of x, right now this is x, y is 2, so f inverse y is equal to x. Okay, so this is important property. And one more step, one more step. If I say x comma y, element of one function f, I must say directly y comma x, element of f inverse. This logic. 1 comma 2 element of f, so 2 comma 1 element of f inverse. Example, 1 comma 2 element of f of x if and only if 2 comma 1 is element of f inverse x. This is for all kind of functions, not only for logarithmic or exponential, for everything. For every function and its inverse, we have this rule. By the way, what can I say about the domain and the range? What is the domain of f inverse function? So domain of f inverse function is set B. What is the range of f inverse function? It is set A. So domain was A here. Now for inverse, it is being range. Domain was B here for the function f of x. Now it is being domain. So domain, range, range, domain. Okay. Now, after this whole explanation, why I have explained this, when I say 2 to the power of 3 is equal to 8, I can express that 3 is equal to logarithm to the base of 2 of 8. And I say that this is like exponential function, and this is now inverse of exponential function, which is logarithmic function. Logarithmic function. Now, for this function, what is the domain? Domain is this. What is the result of this function? Which means that what is the image of this function? It's 3. So if 8 comma 3 element of inverse function, what should I say? 3 comma 8 must be element of my normal function. 8 3 3 8. So what is my normal function? Isn't it f of x 2 to the power of x? 2 to the power of x. So my x is right now 3, 2 to the power of 3 is 8. So to sum up everything, I hope you are not confusing. I am explaining lots of things. 2 to the power of x is equal to y if and only if x equal to logarithm to the base 2 of y. If I call this is f of x, this is now f inverse of x. Check it, please, and if it's not logical, tell me.
No, it's actually clear and logical.
Yeah, it's okay.
So, and for the graphing, general rule, uh, f of x and f inverse of x are symmetric with respect to y equals x. What I mean, if I draw, this is the graph of 2 to the power of x, its inverse, which I can call logarithmic function, would be this. The graph is this. So let me maybe draw better. So I'm not good at drawing. Let's say like this. What do you think? Are they symmetric? Let's check. This distance must be equal. And this distance must be equal. 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 I mean, I should draw well, and they must be equal. So what I see here, my logarithmic functions, logarithm of y to the base 2, will be something like that. So let's think now together, ladies, together. Let's think about the domain of logarithmic function. Do you remember I told you that log x to a, the rule is x is greater than 0, not equal to 0. Be careful, I said, just greater than 0. A is greater than 0, a is different than 1. Domain means this one. Where you have x, it is domain. So when you look at this graph, is this satisfy x is greater than 0? Yes. 0 is here, we don't have anything. Why? This is now vertical asymptote. So everything greater than 0, I have its result. Let me draw again here, something like that. So whatever I have greater than 0, I have result. So this is the graph of the logarithmic function. What about the range? It goes to negative infinitive. It goes to positive infinitive. It's normal. Why it's normal? When we talk about 2 to the power of x, my original function, f function, what is the domain? Domain is from negative infinitive up to positive infinitive. And what about its inverse? So, what about its inverse? Domain will be my range. My range, or let me maybe better here to draw the function f of x, function f inverse of x, and domain and range. Let's check it together. So f of x is 2 to the power of x, which its graph is this, and f inverse of x graph is something like that. So when you look at the graph, or 2 to the power of x, what is the domain? Plus minus everything. So all the real numbers. What is the range? Here, be careful. What is the range of 2 to the power of x? Range is f of x is greater than 0. It cannot be 0. It cannot be negative, but greater than 0. Now, without looking this graph, since by the default definition, domain of function, it's being range of its inverse. So R was here and it comes here. Domain is right now range. And range must be domain. So f of x greater than 0. Let's check now graph. Is the domain of f inverse f of x is greater than 0? Yes, domain means on the x-axis what you have. These are all greater than 0. Now range is all the real numbers. What is range? On the y-axis, what you have? You see now it goes positive infinitive, it goes negative infinitive. So I am right.